Okay, we'll start. Hi, good morning, everyone. Thank you again for joining today. Uh, and we are having our eighth session today in the Train the Trainer series. This is the second one in this cloud tech theme. Uh, so, as a continuation, we are having Srikanth again in this session. We also have Reji from Verizon who has joined this session. So, she is a director of enterprise architecture and cloud at Verizon. And today she will be starting the session, and Srikanth will follow. Reji, over to you. You can introduce yourself and the topics, and you can go ahead. And all the participants can feel free to drop your questions at any time, or you can also ask at the end of Reji's topic. And Srikanth will continue on edge computing after Reji speaking about containerization. Thank you, everyone, and over to you, Reji.
Thank you, Kavya. Like she mentioned, I am Reji Rajendran and taking care of cloud and enterprise architecture for Verizon India. Today, I have my specifically my Kubernetes architect, Jafar, who has joined with me just to answer any advanced questions and very expert questions that you may have in that space. But the idea that I have is to give you an overview of containers and any discussion that you want to do in that regard. Jafar joined with the link that was given to me. So I think for him also the name is showing as Jafar. Just say hello.
Jafar, you can rename yourself, I think so,
Yeah.
from your login. So feel free to do that.
Yeah, sure.
All right. Okay, I'll go ahead and share my screen. Before that, I'm very curious to know if there are anyone who's already familiar with the concept of containerization. If there is anyone, maybe you can raise your hands or put something in the chat. I just want to know, like, if anyone is already working on the container space. If you haven't worked on it, maybe you can say no also. At least I know that there is response. Anyone else wants to say? I see someone has responded with a no. It helps me in understanding what's the level in which we need to take that topic. That's why I asked that question. So I am taking that as a no in general for everyone. Let me go ahead and share my screen. Jafar or anyone, please confirm if you can see my screen.
Yes, Reji.
Okay, thank you. So I know the first session that you had was on cloud and the essentials, basics of it, why we need cloud and all of that. Containerization is a different concept, whether you want to do it in cloud or in your own individual on-prem data centers or anywhere. Containerization is, I wouldn't say it's a newer technology, but a technology that has evolved a lot in the last 4 to 5 or maybe 6, 7 years, which is more prominent amongst the technologies because of its ability to scale and also to have a better resource utilization. So let's go forward. This is the definition. I want to make it as simple as possible for you. But then imagine that if you have to, you all must be familiar with the kind of parcel boxes that you get. If you order meal boxes from any Adayar, Anandabhavan or Sangeeta or something, right? You get one package. It has a little bit of all the different varieties of curries and all of that on the side, and the rice on this in a bigger space. But it is all neatly packed within a small container, and then that is easily portable. You can take it anywhere and eat it. Similar to that, I would say container is a small package that we get to build with the application. If you want to deploy a small application in the production or anywhere, instead of building a full server and operating system and going in heavyweight, we can create a light portable container which has the application and the very essential small set of libraries that are required to run it. So I'll just go through this definition. Container is a lightweight virtualization technology. So all of you may have already heard about the virtualization. If you look at how the whole server industry has evolved, earlier people used to deploy applications in I would say like individual servers. One application will be running on one server. The problem with that is depending on the capacity or the utilization of those applications, there will be a lot of resources wasted. Then came the concept of virtualization, where we decided that, okay, there is one server. On top of that, if you have a hypervisor tool, you can build small virtual machines on that host, and then you can deploy different applications so that there is better utilization of the overall physical server that is there. Now, containerization is taking this whole resource utilization, scalability, and portability to another level, where it is even more resource optimized when you compare it with a virtualization technology. So container is a lightweight virtualization technology that packages an application and its dependencies. Just like I said, you can imagine it like the meal boxes that you get as parcel. Just a small container with the application and its dependencies, just enough for it to run, like the libraries and binaries and config files are required into one file, and it's a container. Now, it can, so the benefits of containers will come through the rest of the slides. But yeah, I think I'll just move on to the next slide. Now, what is the difference between this and the virtualization that you are aware of, right? Okay, the main difference is, imagine that this is a server. Jafar, you can see my mouse movement, right?
Yes. Yeah.
Okay. So imagine that this is one physical server and this is another physical server. So first, we have the infrastructure itself. On top of that, we have the hypervisor plus the operating system component. On that, if you have to create virtual machines, a virtual machine will come with a guest operating system on its own and the libraries that are required to run that application and the application itself. So if there are 15, 16 or more, many virtual machines that may be running on a physical machine, it will have copies of guest operating system, like multiple copies, 16, 20, how many ever virtual machines you are running on a host, that many guest operating system also will have to run on that machine. What it does is it takes memory as well as CPU. Basically, all resources from that physical server, it will get shared for all these guest operating system, making each virtual machine a more heavier, component. Now, when we try to draw a parallel with the containers, the concept is when you have to deploy a container, the same the same physical machine, it have its operating system. On top of that, we will have something called a container runtime or a container engine, which is helping the containers to run on top of the operating system. And if this is a container, it will not need another guest operating system on its own. It has the capability to use the operating system of the physical server in which it is hosted or the cluster in which is hosted. So that is why that makes it a slightly, not slightly, very highly optimized, resource optimized and lighter weight in terms of deployment and portability and all of that. So like I said, so this will help in having more containers deployed because it is lighter weight, resource consumption is also limited. Going to the next slide. In terms of architecture, the concept wise, I'm trying to keep it very high level. So if we look at the architecture, containers has the capability of sharing the same operating system with all the other containers deployed in that machine. But in a virtualization space, each VM will have its own operating system. When it comes to resource consumption, containers are lightweight, consume fewer resources, while virtual machines are resource intensive and higher overhead. Boot time is the time it takes to deploy and bring a new VM or a container, how much time it takes to build one. Because it is lightweight, it is faster, it can be built very quickly. And virtual machines, it will take longer because it has to build its own operating system and put the libraries on top of it and the application. It takes longer than that. Now, when it comes to portability, what is portability? The ability to deploy your application anywhere. So when it comes to a container, once you create a container in your laptop, for example, and it has it is I would say self-sustained ecosystem by itself. And once the container is built, you can run that same container in any environment. It could be in a server, could be in a Windows machine, it could be in a Linux machine. All it needs is to have the container runtime on top of that. Dependency related to the operating system is not there. But it comes to a virtual machine, portability is limited because it is dependent on the hypervisor on which the virtual machines are running, and there is hypervisor compatibility issues that will come if you try to run the same virtual. You cannot move it across. And when it comes to isolation, the concept is, if you're running a virtual machine, how isolated it is in terms of its ecosystem. It has its own operating system, it has its own libraries and applications. So it is at a hardware level, it is isolated. Other than the hardware, it's not sharing anything. But when it comes to containers, it is providing the isolation at a process level because the operating system is shared. Now, which one to use when, right? Both technologies are like not good or bad or anything like that. But what is the best place to use containerization and when to use virtual machine? Now, containers are very lightweight and supposed to have very small amount of app, or the application size is supposed to be smaller. You cannot take a more large monolithic application and just put it into a container and put it there. The whole concept of microservices, I'm not sure how many of you are familiar, but the world is evolving into earlier when we deploy application. If you imagine that you have a portal called Amazon. Yeah, let's take the Amazon portal, all of you are using it. So the entire pages of an Amazon application or anything, Flipkart, Myntra, you take anything, it will be one application if you take olden days. But today, when you have, okay, let's talk a little bit more on that. So what is the problem of it being one application? It could be like if you want to make a small change in the login screen, or if you want to make a small change in the shopping cart. In olden days, it means that you will have to make that change, take the entire code of the entire application, build it together and deploy it all over again. So what happens? It is when there are a lot of, when the application is huge, it makes deployments slower because of the size of it and the dependencies between the different modules within those applications. Always, it's like it can only go together. That's when the concept of microservices came, where we split the applications into small components and deployed separately. So the login can be an independent microservice. Shopping cart can be an independent microservice, and any changes that you want to do in the shopping cart will now not impact login at all. You can just make changes in the shopping cart and then deploy it there, deployed separately. It's a different container. All we need to ensure is that the dependencies between all these different microservices are sustaining, or it is contained, even whatever movement is happening. As long as that is done, whatever you totally revamp the shopping cart also, nothing will happen to the login screen. In the smallest, in the easiest terms, that's how I say. So imagine Amazon as a group or a collection of thousands of microservices. If we have to, and the number of people logging in to browse through the shopping catalog may not be the number of people finally making it an actual buy. So the volume of people using a particular page, hitting a particular page, may be much more than the number of people who are hitting the payment gateway. I'm giving as an example. So the resources required to run the login module, or maybe the shopping catalog or something like that, may be much more than something that is more administrative in nature, maybe like payment. I'm just telling as an example. Or it could be even how many times you will go and change your profile in Amazon, right? So imagine that I am going to go and click on changing something in my profile in Amazon. the number of people trying to do that at the same time may be much lesser than the number of people trying to buy the product itself, by products itself. So the scale in which each of these services needs to run is different. So in such scenarios, containerization makes a lot more sense because each of these can be individually scaled up and down based on the requirements that come in. But now let us, so if you read the different, what are the different scenarios in which containerization suits best? We can say when they are running microservices, when your applications require rapid scaling and deployment, and resources where scenarios where the resource efficiency is crucial. Virtualization is also important when you have applications that require a higher level of isolation, security, where when the applications that needs to be highly secure and has to be isolated at a operating system level and beyond, then virtualization is a better way of doing because there is no sharing of operating system happening. And also when you are running larger applications with different operating systems and things like that. Container use cases are listed on the site. Microservices, when you run cloud native applications, when you are using DevOps, continuous integration, etc. But at a higher level, I would say when you want to run smaller, and when you in a truly cloud native way, if you are creating applications, let's imagine a scenario where you are creating a full end-to-end application stack using Node.js and then a database MongoDB and maybe some caching module and things like that. The entire end-to-end stack can be like 4 different containers deployed, and maybe the application needs to scale a lot more, and your caching may not be using that much of resources. So it will scale up and down independently. Now, if we are just, okay, let's, so then those are the scenarios in which we will use containers. I'll have a little bit more explanation to that in the upcoming slides. Now, this is just an introduction to you for the different container services that are available today in the public cloud service providers that they are giving. Amazon gives Elastic Container Service, ECS, and EKS. In Azure, we have AKS, Azure Container Instance, Kubernetes Engine, and Cloud Run. Now, I want to take your thoughts a level above. Now, we are talking about deploying one container, and then it's scaling up and down and things like that. There are two concepts here. One is Docker. Docker is just one of the tools. There are other container technologies out there like Rocket and other things, but Docker is the most popular one. What Docker helps you is to help you package your application and the libraries into one Docker unit or a container using Docker images. So Docker image is like a template that is used for creating a new container, and every container will have a manifest called a Docker file, which will tell like what are the things that are inside that containers. This is the basic thing that you will be like a Docker container, for example, in this case, will be what you will be deploying across different environments, maybe in your laptop, in your server or something like that. But imagine a scenario where you have to manage a big application which has thousands of containers, and the need for us to scale it up and down. And in some cases, some Docker images may be down, Docker containers may be down, scaling, availability of those, and things like that. It becomes very, very difficult or impossible for us to, if we have to manage it independently, just by managing it with Docker. That is when Google, this concept of Kubernetes came up from Google, and now they have open sourced it as well. It is a container orchestration system. So imagine, like I'm trying to draw a parallel with the whole concept of mailboxes that I was talking about. If there is somebody who has to decide like where all the mailboxes should go, where it should get deployed, if this mailbox is not, if it is not good, then replace it with another mailbox and all of that. If it has to be taken care, when thousands of mailboxes needs to be deployed, we will need some kind of a system or a controller on top of it to ensure that all these meal boxes are, quality wise correct, or it is deployed in the right places. If more meal boxes are there, how to make sure that it is correctly given and something like that, right? Similar to that, Kubernetes will make sure that the containers that are running, like in the earlier example that I said, in Amazon, the shopping cart will have higher scaling requirements, whereas in an admin module where you have to change the profile, it may not need that much of scaling. So how do we manage all the scaling of different containers that are deployed into an environment? Kubernetes takes care of it. So it takes care of all the containers that are deployed, and it will make sure that the scaling is done automatically, and the high availability. If the container is down for a second, how to replace it with another container, all of that management and everything is taken care by Kubernetes. The entire lifecycle management of a container is taken by Kubernetes. Now, what are the benefits? Like I said, first, if you are developing with containers, it makes the development cycles faster because it is independent. You are modularizing your code, and only a small chunk of code that can independently act as a service will get deployed. So it makes sure that there is not too much of interdependencies, and the development cycles for deploying a new feature will become much faster. Now, simplified deployment and management, it ensures like you can deploy it anywhere, and it is improved in scalability and availability because a Kubernetes sort of an orchestration layer will ensure that containers are always scaled, always available, and it can rapidly scale because it's lightweight also. For example, if you have deployed an application in a virtual machine, and if you feel like the usage is high and there is a need for you to scale it out, the time for another virtual machine to come up and take the load is much more than other containers being built and sharing the load. So improved scalability and availability. Similarly, for resource utilization and cost savings, because the container is so lightweight, you can have a lot more containers within a physical server than what we have with virtual machine. Now, that is a very, very high level overview of containers. If there are any questions, we can take it. But containers, while it is lightweight and easier to manage with the help of Kubernetes and all of that, there are other future trends that are out there. One is serverless, where there are services provided by AWS and other, I would say, other cloud providers. You do not even have to worry about managing a server or a container or a virtual machine. All you need is the service. The AWS will provide you I'm just taking AWS as an example, but serverless as a technology will give you the compute capacity. All you need is like you write the code or particular service that you want to be executed. If you are using serverless, you really do not know like what server it was deployed, when it was, how it was executed or any of that. Just the compute capacity will be provided. It is agnostic. You will not see it's abstract, and then you just get the result. Like you want to run a batch job, just go serverless, just run that and get the result. So now cloud providers are also coming up with those kind of technologies. Similarly, edge computing, which is the topic that Srikanth will be sharing, which takes computing closer to the user and which makes it faster. I will let Srikanth talk about it. But these are the future trends that are coming in this space for a more resource efficient and faster computing requirements. That's the high level that I wanted to cover. Are there questions in the chat already, or anybody wants to talk about it, please do.
Reji, I would like to ask a question.
Yeah.
So while applying it in a real world application, what do you think will be the key challenges when moving from monolithic to a containerized architecture?
Yeah, so the key challenge would be the developer should have a minimal knowledge how to containerize their application. So earlier, what happened is the developer has to work with the platform team to set up an infra and host the application, right? Now, any developer can learn the Docker, and they can create the manifest by themselves and create a microservice and host it in the containerized world, right? So that is the benefit. And knowing that the containerization for the developer is an added advantage, right? So they can be well versed with the DevOps field and also in the second infra also. So knowing the developer, the DevOps is an added advantage for the developers.
Two things I would say, Kavya. Thank you, Jafar, for adding that. One, from the developer side, earlier, if they used to just depend on an ops team to deploy their application and let it managed by them. Nowadays, we have moved away from that concept itself because all developers are supposed to know some amount of operations. We call them the DevOps engineer and full stack engineer and all of that.
Yeah.
So they should have a minimum understanding of how to create a Docker file and or a take a Docker image, deploy it and all of that. That's one part. The other bigger challenge is breaking this. We have seen, right? Like when we started off this whole container journey, initially people were keen to move the application to the container world. They take the entire application and move it there, like the monolith itself. So then it doesn't have the benefit of the whole containerization. The whole point is the ability that the container gives in scaling as per the needs of that application. So certain parts of the application will need more scaling and certain parts will not. So ensuring or converting a monolith into a microservice is challenging. It's not like you cannot just deploy 2 pages here and 2 pages there. You really have to convert into a microservices architecture, make it modularized, and only then you can deploy it into containers. So what we would say, so many of the legacy applications go through that modernization journey, but anybody who is building a new application ideally should be building the application modularized by nature. The architecture should be modularized so that they can make use of the benefits of something like a container.
Also, the added advantage here is with the monolithic, right? So if you want to upgrade the application or add any feature, you have to write a code, and you have to redeploy everything into the existing environment, virtualized environment. But with the GitOps model in the containerized world, right, you can add any feature at any time and just have to make changes in the Git repository, and it will automatically push the changes to the containers, right? And it will scale elastically as and whenever it wants. So that's the main feature of this containerization, I would say.
Yeah. So if I can add as well, Kavya. So for your question, I think Reji did touch base. So modularizing the monolithic application and microservices is the architecture style that you would choose, right? And then once you have gone to that journey of identifying that we need to break our monolith into microservices, then you choose containerization, right? Then that is where I think, as Reji was saying, what is the best use cases, right? Then your microservices would fit into each of those containers. So each container will have each microservice. And taking some of the cognitive load, what the future trends that Reji was mentioning around serverless, right?
Yeah.
You need to be wise in terms of choosing whether you go by an instance based or you go a serverless. So serverless is largely pay as you go. So you need to identify, again, there is no one fit for everything, right? You need to identify what is your business requirement, what is the cost appetite your business has got, and then pick and choose. So going Fargate, for example, a serverless thing is pay as you go. It can scale up and down, but the cost might be varying, right? But you might want a dedicated container to run throughout. Then your serverless might cost you more, right? So you need to pick and choose the right deployment architecture and the components based on your needs.
And like I said, how do you decide something has to be deployed in your on-premise environment or to cloud? Maybe you have security requirements that need some applications to run in your on-prem environment. In such cases, we may have an on-prem version of Kubernetes deployed with like OpenShift kind of a system if it is modularized, or you can run on a virtual machine on-prem. Like similarly in cloud also, you can run like Srikanth said, it totally depends on what's the workload that you have and finding the right place for it to get executed in a most resource and optimal way, as well as performance, whatever gives the best performance.
Right.
Okay. Thank you. One more question. So now that you have discussed on what future trends, what do you think is the future of containerization when compared to serverless and edge computing?
I,
In
I
configuration, yeah, I would say, the machine learning and AI, right? So it's taking over the containerization as well. And they are modernizing the AAML platform to use the containerization into the next level. For example, as Srikanth mentioned, this of the serverless environment, right? So even it is a pay-as-you-go service, but it has a higher efficiency compared to the Kubernetes environment, I would say, because it can scale elastically. You don't have to purchase the a warehouse and keep the traditional database and everything and pay monthly rent and everything, right? So you can use as you go, and the artificial intelligence can run in the serverless. Containerization is very much efficient compared to the traditional environment. So they are using the containerization into the next level for the AML based, for also for the edge computing.
Okay. Thank you. Thank you, Jafar. Any other questions from the participants? Please feel free to drop on containerization or edge computing or anything related to cloud architecture. I'm sure Reji, Jafar, and Shrikant can answer.
The main point Reggie was mentioning is the portability, right? You can build a container and run anywhere in the cloud platform. You can run it in GKE, Azure, AWS, and also you can build your own Kubernetes environment by yourself. It's open source. You can just create two instances and run Kubernetes there and host your application. It's open source and it's very portable. That's the
Thanks,
main.
Jafar. I missed to tell that. With the orchestration mechanism like Kubernetes that runs on top of containers, you can run your workloads in any cloud. AWS, if you want a combination, like a, what do you call that, multi-cloud. If you have a multi-cloud architecture, you can go there. You want to run it in your public cloud as well as in your on-prem. Any of that is possible with the help of Kubernetes. Kubernetes will ensure that that whole life cycle is managed across this hybrid ecosystem as well. Thanks, sir.
Yeah.
Are we probably running short of time for the next topic? Maybe we should give it to
Yeah, yeah.
Srikanth.
Yeah, Shrikant, please go ahead.
Thank you.
Thanks, Kavya. Thanks, Jafar. And Reggie, can you hear me okay, Kavya?
Yes, we can hear you. And the screen is also up.
Okay. So let me get into it. So I think Reggie did start with a bit around food, and it's around lunchtime, right? And Arya, Anand Bhavan, Sangeeta, all of this. And I don't know if people are from Coimbatore and Tiruchi and other locations. Obviously, there are other good eateries out there. I was just thinking, right? Like with that, I got some signals within my brain saying that I need something to eat after this. And should it be from Arya Anand Bhavan? How do I send this signal now? And I'm still sitting in this session. What do I do, right? Uh, how can I send those signals out? What if I have gotten a device or a chip embedded within me that can send those signals out into, at least first into my kitchen at home, and then see if that is something available, or send that back into those cloud kitchens available out. Just thinking about that metaphor. And we did talk in the last session around using smart city as a metaphor for microservices, serverless architecture, and event-driven architecture. If some of you have joined that session as well, if you can relate it to it, or if not, don't worry. So if you can just imagine, and if some of you, if you have seen our Indian version of some of these sci-fi movies of Kalki that has come very recently, all those autonomous cars, flying taxis, or people getting shipped from place to place, right? Everything else that I leave to your imagination. We're not far from getting that into reality, right? And we are already experiencing many of those applications in our day-to-day life. And that's where edge computing comes into picture. And the future is going to be anyways unfolding a lot of possibilities for us in edge computing. And why do we need it? And I think I given probably an hungry story, but also imagine where there are some more serious use cases or a good real-time, real-life use cases. In today's session, we'll just see it on the surface, and I'm pretty sure Reji Jaffer, working in representing Verizon, has got a lot to do with. I think they're partnering a lot with cloud providers like AWS in the IoT space. There's a whole lot of developments happening across in the industry, in the globe, across, and you would have been following Elon Musk. He started already implanting chips into human bodies. So that's what I was something, but it might be too costly for us to get it today. But there are other cool real-time applications even that we see today. But this session is going to be just on the surface of edge computing, and then you can start thinking about what potentially you can start applying on in your own work, in your research areas, and in your teaching. So. Okay, so let's look into a bit around theoretical definition of edge computing. I think we spoke a whole lot around cloud computing in the past. What is edge computing different to cloud computing? So if you can see these two images that very much easily understandable. If you take cloud computing, so all the signals and all the data processing is all sent to the one cloud servers. That is where the processing of the data happens. Whereas what we're talking about edge computing is that computation that takes place closer to where the data is getting generated. And we can also talk about where the data is getting consumed in an web application kind of scenarios also. But a whole lot of applications are where the data is getting generated, then relying on the centralized cloud servers. I think we spoke about the smart city in the previous session, and also just think about those smart cities, right? Where you have got the cameras that are set around in the signals and where the traffic is being monitored. What if they detect an accident in that area, right, on the proximity that they have got? And sending it all of that footage into a distant cloud server would take time, and then to get processed and then to react to that or respond to that incident is actually going to be a life threatening thing, right? Like for someone who's really need that help, that medical attention. And maybe we are not there today, but these are the possibilities that are going to get opened up. I think there are cities that have started implementing a whole lot of these devices. So the computing happens at the edge. Like I think Jaffer and Reji also mentioned about those AI ML getting deployed into containers, right? There's a concept of tiny machine language and machine learning language things getting deployed into those smaller containers. So think of these edge devices. You have a car, you have got cameras, you have got signals, mobile devices. Having that ability to compute them, that means identify it. So I think I don't have to talk a lot around AI/ML, but let's say, can they identify that this is an accident, right? Or can they identify a certain object when they detect it? That power is given to those edge devices. Or closer to the edge, if it needs a bit of more power to identify or do the processing, it could be at the edge server than everything transferring into the cloud server. So if you look at the cloud computing, I think largely we're talking about AWS as one example. So AWS has got regions and zones of availability zones within AWS, right? So if you take in India, they have got it in Mumbai and recently in Hyderabad as well. So if you talk about deploying anything into AWS, so you would be deploying in India, if at all. You would be deploying into either Mumbai region or in Hyderabad region, and they do have got availability zones which are located set apart so that they have got the resilience, everything said. But obviously you are transferring data over the internet most of the times, and between availability zones probably is an AWS connect, direct connect they would have. But if you're doing anything through your devices, you're crossing it over the internet, and there could be latency, right, of sending the data. And you're talking about real-time use cases like accidents. We're talking about real-time use cases like monitoring in patient's health or a heartbeat, right? And then there needs to be an action taken immediately, very fast response time that we are anticipating here. So these are the things that edge computing brings is. That means you are bringing that power of computing to the edge. Obviously, containers of those tiny sizes could be one way of how we deploy them into the respective edge devices. So why do we need? I think we were just talking about those use cases. it does reduce edge computing, reduces the latency. So that means you're processing data at that place where it is generated or very much closer to it, right? So every millisecond counts here. I think we're talking about use cases like, my hungry use case, or use case around an accident, your use case around the patient's monitoring, and things like that needs to be very fast in terms of the response that they would require. And obviously for us, that futuristic world, if you look at, this is what we're expecting it to be very, very fast. And bandwidth optimization, obviously you'll have whole lot of data to be sent to the cloud. And then if you have to receive it all, there's so much of bandwidth constraints that you would have. We're taking an example of a smart factory again, right? So where it will have thousands of sensors. Your sensors are set like in highest of like in the peak of the towers and something like that. It all needs to send those raw data to the cloud, again setting those getting those insights and all. So we could do all of this at the edge, right? So you can avoid doing all of this via the cloud fully. So you can optimize the bandwidth and real-time decision making. We spoke a whole lot. Real-time critical events needs that. I think in the previous one of the other session, that when we spoke about event-driven architecture, though we can apply it onto web applications and the other applications that we build, but look at from an this kind of an use case. When something happens, how does we respond, right? And that's an event, right? That event, which device is detecting that event, and which particular alerting mechanism should get triggered, and who should respond next, can all be orchestrated through the edge computing. So we need to give that power over to the edge. I think maybe there are things that have been discussed. We always used to do things at the edge initially. Then we said we have to do everything at the cloud, and then we are now looking at the edge. But then this time around, it's a completely lot different, right? When we're doing things at the edge, they're not just to process in your own browser or as such. We're talking about real-time monitoring and decision making. Kavit, do let me know if there are any questions, if I have to pause, or I would continue.
You can continue for now, Srikanth, if there's something else.
Okay. Right. So how does edge computing works? And again, as we said, this is just at the surface level. We're not going deep dive as such. But look at these three components, right? We have devices at the edge. We spoke about. We have got sensors. And you could actually, in fact, if you're interested in IoT, there are a whole lot of things that you can get out in the market. You can get the Arduino boards, very cheap and accessible these days, unlike earlier. So I do some side projects with my son on IoT. So we do build temperature monitoring systems, humidity monitoring systems, right? Parking systems. So very recently we're doing a parking system. So you could buy these elements out in the market for couple of hundreds. You get Arduino boards. Raspberry probably is kind of a mini computer, so cost is a bit higher, but you could get for 200, 300 rupees, you get an Arduino board, you get Wi-Fi modules in it. You can try experimenting. There are open source cloud websites that are available that you could actually register for and try to do some of this by yourself in a small scale. But we're talking about sensors there, right? Cameras. You can set cameras. So how does the parking lots work? How does Tesla in its autonomous car? How does it work, right? So all these are working through sensors, cameras, and drones. Very recently has got whole lot of all of these being embedded into it. And I just was reading in the paper for Diwali festival season. There's a whole lot of shopping things that are going to happen. So in Chennai, this is in Chennai, but could be something similar out in the other parts of Tamil Nadu as well. So the police department, they are actually deploying a whole lot of drones to monitor the shoppers and manage the traffic efficiently, so that they could avoid all the other things that will happen generally, which is very difficult if you're just on the ground, not able to see what is happening around the whole area. You know how T Nagar would look like in Diwali. So I think drones are coming into that picture, but just flying a drone is not useful, but drone having those sensors and cameras is where it becomes powerful. and edge servers. So where we need, as we said, right, like, so because they're tiny edge devices, they cannot do everything that you would require. So obviously you need some more computing power, so to process some of other data. And it doesn't need to be real time, so right, it might be like batched and send it across, and then it can come back to your edge device and say this is how it is, and get an update for your edge device also. And things like if you look at driving patterns, right, in a Tesla car, you don't need to keep sending every signal every now and then to the edge to process it, but you can send it in a batch, right? In every 15 minutes or every 30 minutes, you could send it to the edge server so that it can process and then generate some insights of what it is. So you do need edge servers. That means they're much closer than the actual cloud servers. So then you got the cloud, obviously, all the power of the cloud for complex analysis and data storage. You then pass it on to the cloud. And in this scenario, this is, we assume that this is not for not an urgent processing scenario, right? So then you send all of the data. So that means all the Tesla cars across the globe start sending data onto the cloud. So then the manufacturer themselves, right, like the Tesla, can make improvements to the whole of their devices, their sensors, their cameras, right, or any other equipment that they need to build it into the next version of it. Similar things would happen with other electric vehicles that we have been getting. So you can see here generation 1, generation 2 of electric vehicles coming in. So the improvements can be done not just by going into the market and studying, but the whole lot of things are getting through sensors, right? They're getting the signals, they're getting the inputs through the sensors, and they can improvise and optimize further. Okay, said that, is it all glorified thing around edge computing? Are there any other challenges and solutions? What for those challenges are? So obviously everything comes with some challenges. Edge computing do have got things, take like security, for example. We are processing data at a lot of distributed locations, right? We're doing it in the devices, we're doing that at the edge, then some to the cloud. And I think a lot of people, you would have heard about some of the malicious actors hacking home surveillance systems, right? Like the CCTV cameras being hacked, and they take the whole control of the CCTV cameras across what is deployed across the building or the campus. So there are solutions of how you could protect them, encrypt the communications across, and ensure that you have got the right security solutions applied. But leaving it, not considering it, actually has got problems around breach of privacy and your data getting lost. You have got market perception, your business at stake, right? So think about security at first. Yeah, I think that applies to even if you're doing any of the other cloud computing as well. But at edge, you need to be a bit more careful around security. And we said about edge being their tiny devices. We cannot make them very heavy, so they will have limiting computing power. So choose wisely what happens at the edge and what can be done, transfer it to the edge servers, in the device into the servers, and then back into the cloud as necessary. So just spoke about that future trends in the previous session from Reji, the AI/ML getting deployed at the edge. So they call them tiny ML. So they're all evolving. They're not like fully there yet, but they're all evolving. And that will allow even a very low power devices to start performing. Like I think the drone scenario we said, it could be low light scenario where it has to do late evenings, right? Monitoring of the shoppers and the traffic. So it needs to identify the images, right? Recognize the images and detect any anomalies, if at all. That means which is abnormal, right? If something is abnormal, it should be able to detect in those kind of scenarios as well. So giving that computing power there, yeah, those are evolving at this stage. And connectivity issues, we spoke about those health monitoring scenarios, right? So one of my colleague previously was working in an US-based company who developed medical IoT devices. So they're very critical, right? So they are next to the patient, and the patients are in a critical stage. So they need to continuously monitor them, alert the doctors as necessary. And so that means they need to continue to function. They cannot just rely on the internet. So because they can lose connectivity to the cloud if they're just through the internet. So they should be able to independently function. So they might have some connectivity issues. So you need to choose rightly what use case you have got, what is that application, where are you deploying, how are you deploying, what connectivities you would require, what can be put into the edge, what can be offloaded onto the cloud if it is not in that real-time urgent processing requirement. So these are just some real-world applications. We spoke about autonomous vehicles, self-driving cars. Tesla was a good example that we've seen. Industrial IoT has been there for some time. That's where you see a whole lot of use cases in the industrial area. So they use it for in factories to monitor and control production lines. Obviously, you can see the productivity improvement of this, right? And this also reduces the times of mission can fail, right? It also like a proactive detection of what can fail at what point of time. So it is not just to respond only after something happens. It can also identify if something is already in a wear and tear situation. It can alert the respective teams so that they can proactively go and fix the problem before it occurs. Healthcare, we've seen all of these glucose meters for diabetic patients. So I think very least is how you connect your Bluetooth from your wearable device and monitor your glucose. But then how can you send it to your local health consultant, right? To your local doctor, or it has to go to a higher order there. So a whole lot of applications in the healthcare, retail, we just spoke about. I think this is something where I think Verizon and Amazon also does a lot of partnership in the retail area. Maybe I haven't got full detail, Reji or Jaffa, you guys can add if I have got more information, but there's a lot around Amazon Go, which uses those sensors and cameras to track customer movements within a retail outlet, right? If you go to an supermarket or a hypermarket, you are tracked and they can actually follow you and see what things that you are picking up. They can send it back to the inventory saying that this is now out of stock. And when you actually do a checkout, you don't really need someone to be there. It can process it at that point. You don't really, again, need complete internet connectivity. So the checkout process can happen at the edge device. I think if you have experienced it, some of the stores, I did experience one recently in Decathlon, right? So you can actually do some checkouts. Your devices are at the edge are equipped with the billing details so that it can does the real billing and you can do the payment and you can check out without the need for a complete a cloud solution to be there for them. Future trends, obviously with 5G, most of us would have got 5G now. There's a lot of potential with 5G, a lot of gaming that is evolving around 5G with low latency connectivity. Now there is going to be a lot of applications that you can start seeing coming in that future world that we are envisioning. 5G is going to enable us much further into that future. That's all I have got in my presentation. If there are any questions, probably I think we have just 3 minutes to wrap it up. Kavya, any questions?
Srikanth, you mentioned about security risks, right? So, can you give some idea about how edge computing will affect data privacy or compliance with, GDPR or similar regulations?
Yeah, so GDPR take biometric, for example, right? If you are recognized as a person and if your biometrics like your fingerprint, right, or your facial recognition are things that are considered to be private, and depending upon each country laws, they would treat them to be an PII data, right? So you'll have to secure them. And if you have got at the edge, you need to ensure that the device that you have got is rightly protected. That means unauthenticated access is not allowed. So you need to find who can actually access it, who cannot. So I think in terms of knowing that what compliance you need to meet for the workload or the use case that you have got. You need to be thorough of which country you are deploying the solution. So India has got DPDP Act, right? Very recently. China, if you get into China, there are a whole lot of privacy related things that they have got. So it depends on which, and if you're into European region, serving for European region, obviously GDPR comes into picture. So you need to be aware of what compliances and regulations that you have to meet and take care of those regulations, but just not from the regulation, but even take from your customer's perspective. So there are certain things like, though this opens up a whole lot of possibilities, I think the challenges and risks are obviously high. So we have to be cautious.
Thank you. Any questions from the participants on Srikanth's topic of edge?
So I want to add one the edge computing evolution that recently I came across. So I have seen in a video there. There is an Apple Fresh store retail shop is open, and when you put groceries or buy anything, you just have to put it in the trolley. When you put anything in the trolley, it will automatically get billed. Okay, you have to just go out. The money will be automatically debited from your Amazon Pay or from the Apple Pay. So that level of edge computing evolution is happening now in US and Dubai. I have seen that recent video.
Yeah, absolutely, Jeff. But I think the Decathlon one was, except the payment, right? I think dropping into the basket and getting it billed, but still I had to go into a queue and do it. But you could still make it very much seamless, right? As you said.
Yeah, that's really wonderful. Yeah.
Nice, Shrikant. Thank you so much for giving some insight on how it's being integrated with emerging tech and making it more powerful. Like you gave the example of IoT and all of that. And also you mentioned about evolving tiny ML, right? So how do you think this is going to change in the future? How soon is it going to scale up? Any perspectives on based on your implementation or something that you have read?
So I think Tiny ML is, I think from an ML perspective, right? So there's a whole lot going around the LLMs. Uh, though LLMs are good, I think we will get into a place where we'll now start doing more contextual models. And within contextual models, that means they do one thing very well. And within contextual models, where you would get into this kind of tiny MLs then. So it does that specific thing very well, right? So it's trained on that data. It's not just the training data, but it also gets the real-time feed into it. So but see, once you get the tiny ML, then it needs to feed back into the somewhere else so that you get an updated models sent back so that it's always up to date. At least I haven't seen any real use cases of them getting deployed, but that's where the future is trending towards. So LLMs would tend towards contextual models very soon.
Thank you so much, Shrikant. I don't see any questions currently. I think whatever questions have been asked, we have answered it. Thank you so much, Shrikant, Reji, and Jafar, for sharing your time, insights, and for answering all the questions. Really lovely session. And also, we have the third session, which we'll schedule soon after we have NTC coming up on November 6th and November 13th at Chennai and Coimbatore. So, once that is done, we'll plan for the third session, wherein we'll explore more on the cloud. And if there is any feedback or particular topic that is of interest in cloud tech, please feel free to put it in the feedback, uh, and we will come back to you with that in the third session, so that whatever is on expectation or on demand, we can address that. So thank you everyone, all the participants also for joining in today, in spite of having your internal exams and model exams that you'll have to evaluate. Uh, and for the experts on the panel today, thank you so much for joining. We'll meet soon again in the next session. Thank you so much.
I want to thank Kavya, the opportunity that I got, NASCOM as well. And it's a pleasure to share the panel with Srikanth. And looking forward to more. I think very importantly, a feedback would be great, especially
Yes,
in
yes, yes.
understanding
Sure.
what kind of topics people are looking for,
Yeah,
or
sure.
rather than us deciding the course of things. Maybe I know, like, we already took some feedback, and some of these
Yes.
were made on decisions were made on what topics
Yes.
should be, like, based on the feedback. Nevertheless, on the delivery and what should have been there, what could have been avoided, it would be great for us also to make sure that we improve next time. So thank you so much for being patient with all of us listening in, and thanks NASCOM for the opportunity.
Not at all. Pleasure is
Thank you.
us.
Thanks,
Thank
Kavya.
you.
Thanks,
Thank you,
Reji.
everyone.
Thank you, Jeff.
Thanks.
Bye.
See you soon. Bye.